Hi, and welcome to Q's Workshop. Today I'm going to continue on the WigWag engine, so this will be part 3. And in part 3 I'm going to be working on the flywheel, some bearings, and then the rods and axle shaft. So rods and axle shaft is probably pretty simple. It's got some silver steel that needs to be cut to size and threaded, so that would be pretty simple. Got the bearing bronze or phosphor bronze for the bearings, so that's just cut to diameter, drill and ream. I'm still waiting for my reamers, so I'm not going to be reaming it yet, but I might just get at least the drilling done, and then I can hand ream it once the reamers come. And then last is the flywheel. The flywheel, I'm going to be using mild steel for the flywheel. So I'm going to, as mentioned in part 1, I'm going to make my flywheel a little bit bigger than the measurements provided on the drawing. And that's because a brass flywheel will carry a bit more weight. So Ade actually does a video where he compares the weights of different flywheels, so brass, steel and aluminium, and the brass is heavier. So what I want to do is I'll be using steel, but I'll make my flywheel a little bit probably wider, just to have a little bit more mass on the flywheel itself. You obviously want to focus the mass probably around the outside so that it can retain that centrifugal force. But I'm sure if I just make it a little bit wider, a lot of that weight will sit on those outer edges anyway. So yeah, let me get started with the flywheel and get this chunk of steel cleaned up. So I'll get you over at the lathe. Just move the tool a bit so that I can get in behind the jaws here, and I've just put a stop on the carriage so that I know where my max limit is, otherwise the jaws are going to hit the tool holder. Right, so I'm trying to take it down to 20 millimeters. So the brass one is meant to be 15 wide. For that extra weight, I'm just thinking about going with a 20 millimeter width, and we'll just take it from there. It doesn't have to be 20 millimeter perfectly. So it's 21.5. That's not too bad. Well, 2020. Oh, there we go. 21.5. Right, so I'm going to start cutting in the recess on the flywheel. So I've already just blued up the front and then with a scribe marked out where the recess is going to be. So all I'm going to do now is just with my tool just mark it a little bit deeper to make it visible, and these are the lines that I'm going to work towards as I'm cleaning it up. Right. I've also got a dial indicator on my carriage so that I can actually measure. So already there I've gone in a bit, so it's going to be off. So if I move to the middle there, so it's zeroed. So I've got to now go in, because I'm making my flywheel a little thicker, so this is 20 millimeters instead of the 15 from the drawings. I'm going to create my recess as 7.5 millimeters on the one side and 7.5 millimeters on the other side. So then I'm still left with 5 millimeters in the middle of the wheel. Alright, that's good enough. Okay, let me get the boring bar in, and then we'll clean up towards the outside. I decided just to turn the tool around, just because this one's got a sharper point on it, and the boring bar is pretty stubby on the end to try and get in there, especially with the small amount of area that I've got to work on there. So I've just turned this tool around, and so all that we'll do is we'll just work our way to into that gap there now from this outside point. 7.6. Actually think I'm just going to leave it there, because I can make the other side to match. So I'm just going to write that down, 7.6, and then we'll match the other side to that. I'm just going to clean up these edges a little bit, put some chamfers on them, and then it will be onto the other side. That's it for the outside. The only thing left now on the flywheel is boring the center out and reaming that, or well, drilling and reaming the center out. So I've just got the flywheel set up in the mill for the last operation, and that's to drill and tap a M3 hole for a grub screw, and that's to fasten the flywheel onto the axle. So I've got an end mill in here just to create a flat spot, and then I'll drill that with a 2.5mm drill, and then we'll tap it. So this is the last operation. Okay, there was a little bit of deflection there, but I'm not too worried about it. It's just for a little grub screw to hold, so it's fine. This was also set up at a 65-degree angle, so I just put a 25-degree angle block on the back of at the back of the flywheel just to set it up. But this can be set up just by eye, as long as you can get a drill past the outer rim of the flywheel, then it should be fine. Right, let's just get a tap quickly. Right, that's the tapping done. Just going to clean off the cutting oil and clean the burr out the inside there, and I'll get you over at the workbench. Next up is the connecting rods, as well as, if I just go to the next sheet, the crank pin. So I'm going to do those three now. So that is this 4mm silver steel rod. It's literally just going to be cutting that to size. The connecting rod and pivot rod gets threaded on the end, so that should be a pretty easy thing to finish off. The axle shaft I'm going to leave for now, because I first want to see where I end dimension wise with the flywheel, and then if we take the flywheel, we take the crank disc, we take the width of the bearings and the column, then I'll know where I fall with the length that I want the axle shaft to be. I want it to be a little bit longer because I want to put a pulley on the end for a little drop hammer or something like that to run on the engine. So I first want to take a look at where I hit dimension wise with all these other pieces, and then I'll know how much to add on, that I've got some additional shaft for the pulley. So I'm going to leave that for now. We'll do that when I'm done with everything else. So yeah, let's get this cut up and just into the lathe to clean it up and get some threads on it. Up now, I've marked 10mm, so I need 10mm worth of thread on this side. The other side I need 4mm of thread. So I've just marked it up on the one side so long. Let's get some thread on it, and then we'll pop the other one in. The other one's exactly the same, 10mm of thread on the one side, 4mm of thread on the other side. So we've got the pivot rod, we've got the connecting rod, and we just got the short crank pin. That's it. Next on the list is the bearings. So I've got the stock for the bearings. The only difference here is the sizes that I needed to change. Firstly, because of the width of the column. So I have to push it up a size. For instance, this one I've got 14.9. It was 11.9, so just 3mm longer, and then the top one also has to get pushed up just by 3mm, because this top one needs to be a bit longer, so it just creates a running surface on the one side as well. Also, the diameter of the axle bearing is now 14mm. And that's because of the surface finish that I originally had in the hole for the bearing wasn't very good. So I pushed that up to a 14mm end mill that I cleaned that hole with. So all that now I need to do is just make this bearing 14mm, the outer diameter. And those all need to be press fit into those two holes. So I'll target 14, but I'll also just give it a feel every now and then to make sure that the bearing fits in there. I have got reamers now for the inner holes. So the pivot point one has to be reamed 4mm, the axle to 6mm. So I've got those reamers now. Right, so let's get the bronze in the lathe and we get going. Okay, 17.7, just over 17.07. Okay, so this has got to go down to 14, so 3 more millimeters to take off. Okay, so that's 14.0, so it's just more than 0. It's not at the 1 yet. It's at the 6 over there, so it's 14.006. That's not a press fit. It's gone too far. Well, instead of it being a waste, I'm just going to use this now to make the other bearing. The other bearing needs to have a 12 millimeter section on it, and then it's got a 14.9 millimeter length and 8 millimeter diameter body. Okay, so we're on 8.13, just over 8.13. And we're looking for 8.11 to make it an exact fit for that. So I think I'm just going to use the file to file it down a bit and get it to the correct size. The build notes do say that kind of the starting edge for press fitting it, you make that a little bit smaller so that it aligns your bearing in the hole before it presses, so that you don't press it, skew and damage the bearing. Okay, so we've got 8.8 now. The front goes in and there it starts tightening up, so I think that's a good. So obviously the front end is a little bit smaller, but that's good because then it can press in. Okay, I don't want to press it in now. Okay, so what it now calls for is a hole 4 millimeters and reamed. Okay, that's the first bearing done. So, just needs to be reamed and it's finished. Alright, back on the axle bearing. So let's get that cut. 14 millimeters diameter, and then we drill and ream it to 6 millimeters. It's got to be 23 millimeters wide. That should be it. Yeah. So there it starts pressing on. It's perfect. You just touch it with a file to make it a little bit easier, but not much. Okay, next up is drill and ream the 6 millimeter. It's too long. It's a good fit on there. The end, I think the end of this just needs to be cleaned up over there as well. But fits in, the first piece fits nicely, it just doesn't want to go through. It's got a burr there, but that fits nicely. Okay, over to the workbench. Alright, so that's everything done for today. The flywheel came out very nice. I just sanded it a bit before I took it out. Surface finish is a little bit rough, but I'm actually thinking on painting the inside of it. There's the little grub screw in there. I was going to drill a little pattern in the inside here, almost to make like little spokes, but the weight of this is already 300 grams, so drilling that out would have just reduced the weight even more. I already tried to make it bigger because I wanted more weight, so just drilling that would just take some of the weight away, so I'll rather just leave it as it is. The bearings, I'm not 100% happy with the surface finish I got. I went as close as I could with the machine and then kind of just used the file to do that last little bit, but the file didn't leave a very good surface finish on it. The front section, you can actually see a little line there, or I hope you can see it on the camera. It's got a little line there, but that's just because the front end of this has got a narrower diameter on it, and that's so that it can fit into the column and align before it gets pressed in. That's just so that it doesn't go skew when I press it. So that's just the two bearings. And then it's just the connecting rod and pivot rod. Pivot rod is almost the same length as the connecting rod because I made it a little bit longer due to the column width being a little bit more. And then also just from sheet 5, I just did the crank pin while I was busy with the connecting rods. It's all the same material. I just cut the crank pin and cleaned up the edges on that while I was about it. But yeah, I guess that's it for today. The next video is going to be the crank disc. There's 2 variants. So one has got a 90-degree bend on it with a round corner, and then this one's got an angle on it. So I'm still deciding which one I want to do, but that will be in the next video. So that's it. I'm going to wrap it up here. Thanks for watching, and keep an eye out for the next one.